All right, students, today what we're going to do is we are going to review the steps to model drawing. And then we're going to actually go and do some math and use those steps. So we always start off by reading the entire problem because mathematicians are also readers, aren't they? And then we underline the question. After that, we're going to take that question and we're going to rewrite it into a sentence. And we're going to leave a blank for our answer. That gets us nice and focused on what am I looking for? What question am I answering? Then we're going to go back to the problem and think about who or what is this problem about? Is there a character in the problem? What's going on? Okay, so that'll be our next step. For step number 4, we're going to actually draw our model, do our bar model. And then, of course, it's math. So we're going to actually do the math, solve the problem. And then our last step is to write the answer in that sentence you created. And also, what great mathematicians always do, we're going to make sure that our answer makes sense. All right, today we're going to use our model drawing to solve this problem about Jake. So we know our first step is always to read the problems. Great mathematicians always read and they reread. Jake is arranging chairs for an assembly. He puts 48 chairs into 8 equal rows. How many chairs are in each row? So go ahead and underline our question so we know what we're focusing on. We're looking for how many chairs are in each row. Okay, so we've read it. Probably we should reread it just to make sure we know what's going on. Jake is arranging chairs for an assembly. There's 48 chairs in 8 equal rows. Okay, I know what my question is. I just need to turn it into a statement now for step 2. So I might say something like, there are blank chairs in each row. So go ahead and write that down at the bottom, giving yourself some workspace. Punctuation at the end, because it's a sentence. There are blank chairs in each row. So when I get done with this problem, I'm going to know how many chairs are in each row. That's what the question's asking me. Okay. All right, so let's draw our model. We need to label it something. We need to think about what is this problem about. Let's see. We have a character named Jake. He's doing something. He's working for somebody, arranging chairs for an assembly that's coming up. And he's got 48 chairs that he puts in 8 equal rows. Can you sort of visualize that? I see the 48 chairs, I see the rows. I just don't know how many chairs are in each row. So I need to draw a model of that. That's what we're gonna draw, is a model of the chairs. So I'm gonna call my model chairs in rows. And then I'm going to draw my bar. Okay. See how quickly we can get through 4 steps? Reading, underlining the question, restating, thinking about who it's about, and drawing the model. So now let's go back through the problem and see what goes in this model. How am I going to break this up? What's going on with the problem? So Jake is arranging chairs for an assembly. We have that. He puts 48 chairs into 8 equal rows. Do we know the total number of chairs he has? Yeah. So where does that go? If I know the total, it always goes at the end. So I'm going to put 48 down here because I know this whole thing is 48. That's what it represents. I just haven't figured out what I need to break it up into just yet. So, do we know how many rows he's putting them in? We know there's 48 chairs. Ah, we do. 8 equal rows. So guess what I'm going to do? I'm going to break this bar into 8 pieces, and I'm going to use what I know about fractions to help me. So watch this. First, I'm going to split this bar in half as best I can. Then I'm going to split each of the halves into halves. So now I have 4 equal parts, but how many did I need? 8. So now I gotta split each one of these into halves, and that's how I end up with 1, 2, 3, 4, 5, 6, 7, 8. 8 rows. And I could label this would be row 1, row 2, R3, R4, R5, R6, R7, and R8. 8 rows. Uh-oh, do I know how many chairs are in each row? So what do I need to put in each one of these rows if I don't know? Question mark, right? So I'm gonna have to go through and say, I don't know what any of these parts are. I have no idea what those parts are. But I'm gonna have to do some math here because that's my next step. So let's see, if I know the total and I know how many parts it was divided into, I just don't know how many are in each part. Wouldn't it be something like 48 divided into 8 rows equals something? I take the total, I divide it into 8 rows, and I'm gonna get my answer. Was anybody thinking this? Well, there's 8 rows, 8 groups of something equals 48. Was anyone thinking about that? That would work too. So even though this is division, it could also be multiplication because they work together. And does anyone know the answer to that? I bet you do. 6. So 48 divided by 8 is 6, or 8 times 6 is 48. So I know that in each one of these, there are 6 chairs. So this is a model of division, and also it could be a model of multiplication using our model drawing. All right, today we're going to use our model drawing steps to tackle this problem that I wrote about myself. So we're going to start with step 1, which is always to read the problem. Mrs. Walsh is organizing a field trip for 16 students. If 4 students can ride in a car, how many cars will she need? Well, let's go ahead and underline that question. How many cars will she need? That's our question. We need to focus on that. So step 2 tells us, let's make it into a sentence. That'll really help us remember what we're looking for. So I'm going to say, Mrs., and I'm just going to put a W instead of writing out Walsh. That would be fine. Mrs. W needs blank cars. Very simple. When I'm done, I'm going to know how many cars I need. So I already have my label right here for me. So let's see, let's draw our model. This is about me. I'm the character. It's about me organizing a field trip. I know that I have 16 students and I need to get them in some cars. And a car holds 4 students. So I think what I'm going to do is label this students. I'm going to label my bar students in cars. And then I'm just going to go ahead and draw my bar. Okay. So I've started my model. This bar represents students. Okay. So now let's go back through the problem and see what do we need to put in our model. Mrs. Walsh is organizing a field trip for 16 students. So do I know how many students I have total? Sure. So what I have to do is put it at the end. If I know the total, I'm going to put it at the end. To represent, this is 16 students. If 4 students can ride in a car, how many cars will she need? So here's car 1, right? I'll just put C1 for car 1. And how many students can ride in that one? 4, right? Okay. So, I don't know how many cars I need, do I? This right here is the big question mark. This piece right here, I have no idea. Notice I made that fancy bracket again. Remember, you can just make like a V or something if you want. I don't know how many cars I'm gonna need. Okay. So there's a couple ways I could do this problem, because now I have to figure out the rest of the model, I have to do the math. So here's what I'm thinking. One thing I could do is I could say, well, I have 16 students, and I know I'm going to divide them into groups of 4. So 16 divided by 4, good thing I learned my multiplication facts. And I know that 4 times something is 16, and it's 4. Okay? So every time I have a car with 4 students, I'm going to get to the point where I need 4 cars. Now, let's go ahead and put the answer in here, but I want to compare these two problems that we've just worked. In the chairs problem, we knew the number of groups, but we did not know how many was in each group. In this problem, we didn't know the number of groups, did we? But we knew how many went in each group. So that's 2 different types of division. But it doesn't matter, either way, you can use our model drawing to solve both types of division problems.